This is the subject of electronics. This is the branch of electronics and communication, and the subject is electromagnetic theory. Today's the topic is steady electric field. Now we start our lecture. The steady electric field, it is defined as it can be analyzed using principles like the superposition principle for multiple charges and Gauss law for symmetrical charge distribution. How we can find the steady electric field with the help from the multiple charges and for the calculation the field from each charge individually, add them as vector. To use Gauss law, choose a symmetrical Gaussian surface and determine the enclosed charge. So we use this expression, integration of E dot ds is equals to q enclosed epsilon naught. Now the next topic is Coulomb's law. It is defined as the fundamental law of electrostatics, which states that the electrostatic force acting between two charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between the charges. That is, F is equals to K dot Q1 dot Q2 divided by distance, that is D2. Here, the Q1 and Q2 are the static charges and the D is distance between these charges. Now the next topic is Gauss law for electric flux. The Gauss law for electrostatic gives the value of electric flux, which is phi E is equals to charge upon epsilon naught, that is permittivity. The next is electric field intensity, the space around an electrically charged body in which a test charge experiences a force of attraction or repulsion is known as electric field, and the strength of force acting on the charge placed in the field is called electric field intensity, which is denoted by E, capital E, and is measured in the unit Newton per Coulomb. E is equals to F upon Q. This is the expression for the electric field intensity. Now the inductance, it is the property of material by which they store electrical energy in the form of magnetic energy, and it is denoted by L and measured in the capital H. And the expression is L is equals to capital N dot phi divided by current, that is I, where the N is number of turns in inductor coil and phi is the magnetic flux. Now the topic is capacitance. It is defined as the property of substance of storing electrical charge in the form of electrostatic field, which is capacitance of the substance, and the circuit element used to introduce capacitance effect in an electric circuit is called the capacitor. It is denoted by capital C and measured in farad and derived as the expression C is equals to Q upon V, where Q is the electric charge accumulated on each plate and V is the voltage across the plates. We may also express the capacitance of capacitor in terms of physical dimension, which is C is equals to epsilon A upon D, where epsilon is the permittivity of medium between the plates, and A is the area of cross section of capacitor plates, and D is the distance between the plates of capacitor. Now the topic is divergence. It is a vector calculus operator that measures magnitude of vector field of the source or sink at a given point. Or in other words, it can be defined as how much a vector field spread out diverges or converges at that point, where the divergence of F in the form of expression is del dot F, which is equals to del F1 by del X plus del F2 by del Y plus del F3 by del Z, where del is the divergence operator, dot product of del operator del with vector field F. Next is curl. It is also a vector operator that describes the infinite rotation of vector field in 3D space. In other words, it measures the tendency of the field to rotate around a point. The curl of a vector field provides information about the rotational motion or the twisting of the field lines around a given point. Where F is F1, F2, F3 in 3D space, and these are the components of vector field. The curl of F del cross F is equals to this expression del F3 by del Y minus del F2 by del Z, comma del F1 by del Z minus del F3 by del X, comma del F2 by del X minus del F1 by del Y. This is the curl operator, which is cross product of tail operator with vector field F. Now the equation of divergence and curl are integrated in this slide. The curl equation is del cross F, defined in the unit vector direction of I, J, and K. Divergence equation is del dot F, where F is calculated in the form of Px plus Qy plus Rz. Now the divergence of curl, this expression is always 0, del dot del cross F, and the curl of gradient del cross del F is also 0. These equations play crucial role in vector calculus, describing the rotation and flow properties of vector field, as well as the relationship between divergence and curl. Now the scalar potential, it is defined as a scalar field whose negative gradient gives original vector field, and defined mathematically as force equals to minus del phi, where del is the gradient operator. The next is vector potential. It is a vector field whose curl gives original vector field, and defined in the mathematical form V is equals to del cross F, where del cross is the curl operator. Thank you.